This will be for the con exercise, distance between point and line. All right, so when you find the distance from the point to the line, you're basically finding the perpendicular distance. Okay, you're going to be creating another line that's perpendicular. So the four main steps. First, you want to find the slope of the original line. Okay, if you recall, the slope is basically change in y over change in x. All right, so that is your slope. And you just have to go on the graph. Well, you might get the equation. Otherwise, you just go on the graph and count change in y over change in x. So that's for the original line. Step 2, you take the negative reciprocal. Okay, remember the two steps. You want to flip it and change the plus minus sign. Step 3, you're going to apply that new slope from the point to the line. So basically, you're going to draw in another line that's perpendicular. And then step 4, you're going to use the Pythagorean theorem, a squared plus b squared equals c squared. Okay, you can also use the distance formula, but I think this is a little easier. So you're going to see that on the graph. All right, so those are going to be the four main steps. All right, first problem, find the minimum distance between the point 3, 1 and the line y equals negative 1/2 x minus 5. Enter an exact answer with a square root. Okay, make sure you do that at the end. Now, here's the point, here's the line. We can go on the graph and find the slope of this line. However, in this case, it's convenient because they gave us the equation. Okay, recall that let me fix this here. Recall that the standard line equation is y equals mx plus b, where the letter m represents the slope. So if the equation is in that form, just look for the number that's times x, and you can see right here, we have the negative 1/2 times the x. So the slope equals negative 1/2. All right. So remember the two steps for the negative reciprocal. All right, I'll just write it on top here for the negative reciprocal. Step 1 is to flip it. And step 2 is to change the plus minus sign. All right, so let's take the negative 1/2, flip it, so you keep the sign for now and flip this. It's going to be 2/1, and then change the plus minus sign, so it's positive 2/1. Okay, and this is going to be the new slope. All right, so that's the first two steps. Find the slope, take the negative reciprocal. We got that out of the way. Now we said we want to apply this new slope going from the point to the line. So let me see here. If the new slope is 2/1, what's the translation of 2/1? Both positive. Well, the numerator is the change in y. That's the up-down part. And since it's positive 2, that means you go up 2. The denominator is the left-right part. Since it's positive 1, that means you go right 1. Now, if we went up and to the right, we're basically going this way, but we want to go to the line. So in addition to this, you can also do the opposite. Okay, so instead of up 2 and right 1, I'm going to go down 2 and left 1. Okay, I'm allowed to do the opposite. If I do the opposite of both of these, that's the same thing. If I go up and to the right, that's the same as line as going down and to the left. All right, so that's what we want to do. Down 2 and left 1. So start at the point. Go down 2, 1, 2, and then go left 1. Left 1, okay, and you got a point there. Now do it again. Down 2, 1, 2, left 1. Right there, you got a point there. Finally, one more time. Down 2, 1, 2, and left 1. There you go. You got a point right there. All right. And now you can use the distance formula, or you can use Pythagorean theorem. All right. I'll do Pythagorean theorem for now. Let me erase this mess right here. All right. So I'm going to construct this line here now that I have the 2 points. You can keep the other points in there if you want, but you don't need them. You only need 2 points to construct a line. All right, so this pink line here is the perpendicular distance. This is going to be a right angle right here. All right, and so we're looking for the length of this line in pink, line segment. And now you can use Pythagorean theorem or the distance formula. Okay, let me erase this right angle here because I don't want to confuse you. I'm going to construct a right triangle. We're finding the length of the one in pink. Okay, so I'm going to make a right triangle here. I have to either go straight up and down or straight left and right and connect these points. Okay, so let's see. I'm going to make a right triangle. I'm going to go 1, 2, 3 units here. All right, don't worry about positive or negative. And then going up, I'm going to do 1, 2, 3, 4, 5, 6 units up. Okay, and now this is a right angle here, and I can use my Pythagorean theorem. All right, a squared plus b squared equals c squared. Remember that c is always the hypotenuse. That's the one across from the right angle. Okay, a and b, it doesn't matter which is which, so I'll let this equal a, and I'll let that equal b. Okay, c has to be across from the right angle. The other ones, it doesn't matter. So a squared is going to be 6 squared. B squared is going to be 3 squared. And that equals c squared. 6 times 6 is 36. 3 times 3 is 9. And that equals c squared. 36 plus 9 is 45. And that equals c squared. The opposite of squaring something is to take the square root of both sides. So the square root of c squared equals the square root of 45. All right, square root of c squared is just c. And they told us we could enter a square root as is. All right, so we don't want to do the decimal on that. We want to keep that as is. So the length of this pink line segment is radical 45. We're going to enter that in the box. Okay, now if you don't like Pythagorean theorem, you don't have to use it. All right, if you don't want to make a right triangle, you don't have to use it. This is what you can also do. You need to get the coordinates if you want to use the distance formula. So this point here, the x coordinate is 3, and the y coordinate is 1. This point here, the x coordinate is 0, and the y coordinate is -5. Okay, and you can use the distance formula from 3, 1 to 0, -5. If you remember the distance formula, you subtract the x's and you square it, and then you subtract the y coordinates and you square it. Okay, so if you want to use this formula instead of Pythagorean theorem, you can do that. The only thing is, if you want to use this formula, you need to get the coordinates. Okay, for Pythagorean theorem, you need to construct a right triangle. I think this is a little less work, but you're free to do this if you like. All right, so click in the box, click this button here, and look for the square root symbol. All right, I think my screen is too big right now, but anyhow, there should be a square root symbol somewhere. If you can't find the square root symbol, you can type SQRT, and it gives you the square root, and then underneath you can just type 45. All right, find the minimum distance between the point 2, negative 1, and the line y equals 7. Okay, so if you get one with a horizontal or vertical line, you can see right here. You can see right here we have a horizontal line that goes through y equals 7. This is actually very easy, okay? Because since the line is horizontal, the perpendicular line is going to be vertical. All right, so all you have to do is count going from the line to the point. All right, so if we count, we got 1, 2, 3, 4, 5, 6, 7, 8, and that's it. Okay, the distance from the point to the line is 8 units. Okay, very simple. If you want to do it mathematically, this point, this y coordinate here is negative 1. Okay, so if you went from negative 1 to 7, you just subtract and take the absolute value. So 7 minus negative 1, 2 negatives in a row make it positive, and 7 plus 1 is 8. So you can do it mathematically, or you can just count. But when the line is horizontal or vertical, it's very easy. 8 right in the box. All right, another easy one. Find the minimum distance between 2, 2 and the line x equals 6. Too easy, all right, because they already gave us a vertical line. The perpendicular line is going to be horizontal, so just count. 1, 2, 3, 4. That's it, done. We went from x equals 2 to x equals 6. 6 minus 2 is 4. All right, last one. Find the minimum distance between the point 2, 6 and the line y equals negative 2x. Enter an exact answer with a square root. All right, so remember the line equation y equals mx plus b, where m is your slope. Okay, m is the number that's times x, so we can see right here that the slope m is negative 2. All right, so finding the slope is the first step. The second step is to apply the negative reciprocal. So we have negative 2, and you can certainly make it negative 2 over 1. That's the same thing. And the 2 steps, flip it, so keep the negative and flip it. Negative 1/2, and then change the plus minus sign. So that's positive 1/2. All right, so we have the new slope, and we want to apply that going from the point to the line. So what's the translation here? Well, positive 1 in the numerator, that means up 1. Positive 2 in the denominator means right 2. Now, if we went up and to the right, we're going that way. We really want to go that way. All right, so instead of up 1 and right 2, you can do the opposite. Instead of up 1, I'm going to go down 1. And instead of right 2, I'm going to go left 2. All right, so let's do that. Starting at the point. Down 1, left 2. All right, down 1 is here. And then left 2 is 1, 2. Down 1 is here. Left 2 is 1, 2. So we're right here on the line. We're good. All right, I can erase this. And again, you can certainly use distance formula, but I like right triangles. So right here is the line segment length we're trying to find. All right, so I'm going to construct a right triangle. All right, so when you make the right triangle, the sides have to be up and down or left and right. So let's go down first. 1, 2. That side length is 2. And then go to the left. 1, 2, 3, 4. Okay, that side length is 4. You don't need to worry about positive or negative because we're dealing with side lengths of a triangle. So they're always going to be positive. And here's the right angle. And across from your right angle, that's your hypotenuse, C. All right, I'm going to do A squared plus B squared equals C squared. All right, A and B, it doesn't matter which is which. So I'll let 2 equal A and I'll let 4 equal B. Okay, don't worry about this stuff here. So let's see. A squared is going to be 2 squared. B squared is going to be 4 squared. And we're left with C squared. 2 times 2 is 4. 4 times 4 is 16, and that equals C squared. 4 plus 16 is 20. And since C is squared, the opposite is to take the square root of both sides. All right, the square root of C squared is just C. Square root of 20, that's a decimal. We do not want a decimal. We want to leave that as is. So square root of 20 is your final answer. Again, if you want to use distance formula, you certainly can. This point here is at 2, 6. This point here is at -2, 4. And if you want to use the distance formula, you can do that. I like the right triangle better, and my answer is radical 20. So in the box, you either click here to find the symbol or type SQRT for square root. See that? It gives you the square root. And I said it was radical 20.